Oh, hey everybody, welcome back. Part 3 coming up right now. So we're just picking up where we left off. We have example number 2. This one is completely different. Okay, in example 1, we were given a random graph, no equation, and we were just asked for bits and pieces of information. This time out, okay, we are going to sketch a rough graph of this function below, and it's already in factored form. So because it's already in factored form, okay, we do not need to use synthetic division or factor theorem or possible roots or any of that stuff, okay? We can get right to the factors. Well, the factors are given, sorry. We can get right to the roots. The roots or x-intercepts are the opposites of the factor. So notice right here, I can write out exactly what the x-intercepts are. There's one at positive 3. There's one at negative 2. And there's one at positive 1. But let's just recall what we learned from part 1 of this video, the multiplicity. Okay, you can take a look at these 3 factors here, and one of them has an exponent of 2. So x minus 1 to the power of 2, that results in the factor giving you the root number of positive 1, but that has a multiplicity of 2. So we're going to write multiplicity of 2. Not sure if it's of or just multiplicity 2. I don't think the word of really needs to be there, but that's irrelevant, all right? We just know what kind of graph this produced. And then these other ones, you could write in that they have multiplicity 1 if you want. What I like to do is, if it's multiplicity 1, I just leave it alone, all right? And it's the 1 is assumed to be there, and I only make a note of it if it's 2 or 3. So right away, okay, if we sketch this graph, we know what the x-intercepts are. So that's a great place to start, and we can start right there if you wish. All right, we can just sketch a quick x and y axis. You can check your work on Desmos, of course. I'll leave Desmos out of it for now, but notice here, okay, I am doing x-intercepts at positive 1, positive 3, and negative 2. Now, that helps out. How do I know exactly where the graph goes? Well, first of all, look at the question. It says sketch a rough graph. Okay, this is not going to be too specific, but we definitely want to have the x-intercepts in of negative 2, positive 1, and positive 3. We can also get a y-intercept. Now, if this was not in factored form, we could just look at the constant term, and that would be our y-intercept. Because it's in factored form, we don't really have a constant term at this point. But what I could do for any equation, not just polynomials, any equation in general, is I can plug in 0 for x and I can get a y-intercept. So watch what I do right here. Okay, I'm going to plug in 0 for x, and I'm going to do my order of operations. I'm going to do brackets, then exponents, then multiplication. You guys can do all that on your own. This is going to give you a negative 6. Or, if you want to write it as a coordinate point, 0, negative 6 is our y-intercept. And again, okay, I could probably squeeze negative 6 on my y-axis. If you get a y-intercept of like 24 or 36, you could just estimate it. You could just mark off a point and just write in the y-intercept, and that would be fine. But that gives us another point on the graph. Now what we can do is we can use our end behavior. Okay, so we're going to look at our end behavior chart at this point. And first of all, we have to figure out what type of graph this is, or what type of degree function. But once again, okay, if you go back to your original equation, we can do this in 2 ways. Okay, we can look at the original equation in factored form. You have x minus 1 squared, that's degree 2. X plus 1, that's another degree 1. And x minus 3 is a degree 1. So 2, 1, and 1 give us a degree 4 function. Or you could look at the multiplicity of the roots. So if you go down one step before that, you see the roots circled there. We have multiplicity 2, multiplicity 1, multiplicity 1, 2, 1, and 1 is 4. This is an x to the 4 function. Is it a positive or negative? Well, look at your original equation, and you do not see any sign in front of the first bracket. There's no negative sign there, so it's assumed to be a positive. And then a positive x to the 4 starts in quadrant 2 and ends in quadrant 1. That's going to be helpful because now we have to sketch our graph. We know we're starting over here in quadrant 2 and ending in quadrant 1. So we know we're going to start over here, work our way through this x-intercept. definitely hit up the y-intercept down here at -6. Then we go up to x equals 1, but we remember that this is multiplicity 2, so it has to bounce off of it, and then it cuts through x equals 3, that's a multiplicity 1, and ending in quadrant 1. So when you're drawing these, especially at first, okay, you may want to use pencil. There may be a little trial and error. You try to do this, but then this doesn't work. But there's only one possible way that we could draw this to hit all those points and to make sure that the x equals 1 x-intercept is a bounce. All right, it doesn't just slice through. The other two x-intercepts do. And then if you take a look at this right here, okay, there are some things that are not specific. For example, if you look at what I'm circling here, we don't know how low or how high that point goes. Okay, when it dips down, we don't know how far it dips down. We're actually going to take a second look at that when we move to calculus next semester. And then there's some other specific points on the graph that we don't know either. Okay, so we just have a basic shape. We want to make sure we have x-intercepts with the correct type of roots. Types of multiplicity. We want to make sure that we have the y-intercept correct and the end behavior. Okay, so you guys are going to try out this question right here. Perhaps you may want to pause the video, try it on your own, and then return back in a few minutes when I work this out. And so you're going to hit that pause button right now. And okay, now you've unpaused. Let's check this out. We have x is equal to -2. X is equal to -1. Those are the x-intercepts. Okay, this is multiplicity of 3. This has multiplicity 1. So we know that when we sketch this graph, and again, this is just a rough sketch, and you can check your work on Desmos. Okay, feel free to do that. We have an x-intercept here at -1 and -2. The y-intercept, okay, if you plug in 0 for x into the original equation, you are going to get -8 or -8 comma 0. So once again, okay, I can fit -8 on the graph. So I'm going to put -8 here. Okay, and then the end behavior, this is a negative x to the 4 graph. This is degree 4 as well, and once again, you can look at the factors and see x plus 2 to the 3 and x plus 1 to the 1. 3 and 1 give you 4. Or you can look at the multiplicity and see multiplicity 3, multiplicity 1, that's multiplicity 4. Okay, it's negative because of this negative in front of the equation. All right, so we have a -4. You look at your negative x to the 4, negative evens. They start in quadrant 3 and end in quadrant 4 according to your end behavior chart. Or you may recognize that this is like a upside down W, which produces an M-shaped. You're going to see some differences in this one because the multiplicity 3 root, but the end behavior is always the same. So let's take a look at this. All right, at -2, okay, so we start here in quadrant 3. We get up to -2 here. And then watch what happens. This is a triple root or root of multiplicity 1. So I know here at -2 it has to slither through the x-axis because it's multiplicity 3. And then at -1 it can slice through the x-axis once again. And again, I don't know how high this peak here goes. It could go up a lot higher, or it might be lower. We don't really know. But we also know that it cuts through the y-axis at -8, and it also begins in quadrant 3 and ends in quadrant 4.